Hi, welcome to another MATLAB Crash Course series video. My name is Stephen Yagmore, and today we have another lecture, user input and output. And so some of the topics we're going to be looking at today, we're going to be looking at input using the input function. We're going to be looking at output using the disp function. We're going to look at output using the fprintf function. We're going to look at other characters with fprintf. We're going to look at placeholders with fprintf, and we're going to look at padding with placeholders. Now, some of these may seem, as we get started, they may seem a little counterintuitive because everything we've been doing so far has taken place in the command window of MATLAB. But hopefully in the next video or next couple videos, I'll explain how we can actually use these functions more to our advantage. In this lecture, I'm just going to get started and explain the functions so we can use them in later videos. So first I'm going to begin by talking about input using the input function. So one can allow the user to enter specific input values to MATLAB by using the input function. The input function allows for one to have a message be displayed before halting so that the user can enter a value. So essentially the input value will display a message, and then the user can enter their own number in, like the user, the person using the laptop. MATLAB will display a message, the user can enter a number, and then that number will get saved in MATLAB. And the best way to show this is by looking at an example. So the input function is used as follows. Input, enter a value here. This function will display the message and wait for the user to type either an integer or a float value or vector into the command window. So if we use a format like this, the user has to enter either a number or a decimal into the command window. So let's actually do that example. So let's say we use the input function, and we could say, let's see, I could say input, enter a value here. And then I want the user to essentially enter a value. And when I click enter, that message gets displayed. It says enter a value here. And so when I do this, I can enter either an integer or a decimal. So I can put like 45, and the answer gets saved as 45. But I could do this again, and I could enter a float value. So I could say enter 90.8. It'll save it as 90.8. It works exactly as we'd expect it. However, if I try using that function, and then if I do this and try entering a string or a character, it won't work. So I can't type the letter C in here, because if I do that, it'll say it'll think it's a variable. It'll say undefined function of variable C. So I have to enter a number or a float variable in there, and it'll work properly. So let's say I do want to enter a string or a character there though. If I use input, enter a word here, and then as a second argument, put this S in single quotations, it will display the message and wait for the user to enter a character or string into the command window. So if I want the user to enter a string, I have to use that S as a second argument. So I could say input, enter a word here. And then as a second argument, I put the %S. Enter a word here. So I could put, I don't know, my name. So I could say Stephen. And then it will save that as a string. It'll save the word. You can actually use that. If you don't include this S in single quotations, you cannot put a string or character as the answer. The input function is commonly used in order to save a variable. So here we just had it display the message, and then the user inputted something. But what we can actually do is use the input function to have the user store a variable for themselves. So here I could say, let's say I want to make a variable. So I could say num. I could say num equals input, enter a value. So now I want the user to enter a value. So let's say I want the value to be entered, I'm going to say 32. So now num equals 32. And if you look in our workspace over here, num is now a new variable. So I can use that variable then. I could say num plus 7, and it'll do the mathematic operation. So the user entered a value, and then MATLAB stored that value. This is a really common way for the user to interact with MATLAB directly. Generally, one will assign the result of the input function as a variable. That's what I discussed, where you assign it as a variable and everything works out. You can do mathematical operations for it. Now, once again, this might seem a little counterintuitive because we can just do those operations ourselves. Why do we need to ask for a value? But once again, in future videos, when we start writing scripts, you'll see that this is a way for us to interact with the user without the user seeing all the code and everything necessary. Now we're going to talk about some output in MATLAB. So output using the display function, or the disp function. So the disp function allows for one to display a value or string to the command window for the user to view. So one can simply display a value such as display 6 times 3. It's fairly straightforward. Let's clear this here, clear my variables. So I can say display 6 times 3, and it will simply just display the answer. It doesn't save it as a variable, doesn't do anything. I don't get answer equals. It just displays the answer. It says the answer is 18. Similarly, we can use it to display a string or display a message, such as nice to meet you, using the display function. So I can display nice to meet you. And it will simply just display the message to the command window for the user to see. It's just a simple message, then I can type whatever I want after. Every time the display function is used, the user can begin typing on the next line. So this might seem fairly intuitive, like, yeah, okay, displays the message and we start typing on the next line. Like, as you see right here, it displayed this message and I can begin typing right here. This might seem obvious, this might seem like something not worth pointing out, but you'll see on the next slide that not every output function behaves like that. And it's nice to note that if you use the display function, if you type something or display something, you can automatically begin typing on that next line. This function does have a few drawbacks though, as it does not allow for any formatting when displaying elements. So you might question what formatting means exactly, but we're going to get to that in the next slide. So because we can't format with it, display is generally not used that often compared to the other output function we're going to talk about, the fprintf function. So a more common option for displaying text on the command window is by utilizing the fprintf function. Unlike the display function, fprintf cannot simply display any numerical values simply by entering the value in the function. So that means that fprintf of 45 would not be a legal declaration in MATLAB. In fact, we can even try that here. So I can say fprintf of 45, and then we're going to say there's a formatting error, no format character vector, error using fprintf. Fprintf does not allow for just a number to be put in there. It just simply will not work. The fprintf function can simply display a message, though, similar to display. We can do it to the command window in a similar format to display. Fprintf, how are you today, will simply display the statement to the command window. However, unlike the display function, fprintf will not start a new line after the statement is printed. So that's what I mentioned earlier with the display function. It began a new line, but let's see what happens with fprintf. Fprintf, how are you today? Let's see what happens. So it prints how are you today, but look at where the two greater than signs are. That indicates that I can type there. It's in the same line. When I type something, it's in that same line still. It doesn't start a new line like the display function. If I want to go to the next line, I have to click enter. So why does it do that? That's because fprintf is very specific with its formatting, and you have to be very careful when wanting to know exactly what you want to print on the command window. There are multiple extra features to fprintf that are not included in the display function. That's what makes fprintf a lot more powerful. There's a lot more we can do with the fprintf function. And that's what the bulk of this video is going to be on, is using this function and what all this function has to offer when displaying values or statements to the command window. Let's look at other characters with fprintf. So fprintf is far more powerful than display because the extra characters can be used to format the output in a specific manner. So there are special characters that we can put in that string that we have, in the string with our message. We can put special characters to format our output a little bit differently. So let's look at some of the basic ones. So \n will start a new line before printing whatever's left of the message. So remember how I said it doesn't start a new line? It didn't start a new line because we didn't include this \n character in our string. So let's do the same thing we did last time, but include this character. So if I type fprintf, how are you today? And then right where I want the new line to start, I include \n. I close my parentheses, I close my quotation, close my parentheses. Now what this will do is it will display how are you today, but then create an extra line. It will \n, it'll start a new line, leaving me at the next line. So it printed how are you today, but unlike the last time, it actually put down a space. It entered a new line. We can put this at any point. It doesn't have to be at the end of the string. We can put this at any point in that string we have. I can type fprintf, how are you? I can put a \n, and then I can put today ? Notice I didn't put a space in between any of this. I just put you, put a \n saying I immediately wanted to jump to the next line. And then if I put a space here, it would put a space after the start of the new line. I just want it to immediately start typing, so I'm just putting everything together. So how are you today? I'll put another \n, meaning I want it to then take me to a new line after printing the second line. I close the quotation, close parentheses. Let's see what happens. So it said, how are you? \n, so it went down to the new line. Today, another \n, so I go down again, therefore leaving me right here at the next line. Let's see what happens if I put a space here. So if I left a space here, which maybe looks more normal, there's now a little space here before the today, and that doesn't look as nice, which is why I did not include it. The \n is really common when using fprintf. Generally, if you use fprintf, you're going to also be using \n a good bit. This is probably the most important character that you know out of all these I'm going to mention. So, but it's similar to \n, we also have this character here, \t. And what that will do is that will actually place a tab before printing whatever is left on the message. So let's just do a couple examples here. So I'll say fprintf, and then I can just simply just put, say, a \t, just so we can see here. So you can see it leaves a little space before it gives me the two greater than signs. It just gives me a little tab. That's what, tab is. It's a few spaces. So I can say fprintf, for example, hello, \t, there. I can put a -n to start a new line. And then you can see hello, and then I have a little tab here. There. The \t isn't too common, but you can use it if you want to create some spacing for your formatting when you're printing out these characters or strings or whatnot. Not nearly as common as the \n though. If you want to actually place a / character in your string, you have to use two backslashes. And this might seem a little weird. Why not just place one? Well, if you use a backslash, MATLAB's going to think that you might be doing something like \n or \t. So to avoid confusion, if you place two backslashes, MATLAB knows that that's just a single backslash. So let's actually try it here. So I could say fprintf, this is a backslash. And then to print the backslash, one backslash will not do, so I do two. And that will actually display a backslash. So let's try this here. This is a backslash, and it displays a single backslash. I don't like that it starts at the same line though, so I'm going to format it a little differently. So this is a backslash, so I put two for a single backslash. Then to start a new line, I put \n. So it looks like a bit, but if you print it out, it makes sense. This is a backslash. Two backslashes means a single backslash, and then the \n means start a new line. So that's how you would format all this. Two quotation marks must be used to place a single quotation mark. And so this might seem weird again, like why are we using two? But let's take a look here. So let's say I want to print a quote. So I use quotation marks to start, the string, and I can say my mother said, and then when you start a quotation, use quotation marks. Okay, you can already see something's up because this text is purple and this text is black. So this looks like just trail text. Let's see what happens. So she said, do your homework. And then I close my quotation and I close the string. So like this is how you'd format it if you just did it normal. So we get an error. And that's because when you put that quotation mark, it actually thinks that you're ending the string. But you don't want to end the string. You want to just put a quotation mark as a string. So once again, just like the backslash, MATLAB will recognize two quotation marks as a single quotation mark. And the best way to do that is just as an example. So let's try this right here. So my mother said two quotation marks right here. So MATLAB will read that as one quotation mark, do your homework. Two quotation marks, MATLAB reads as one. And then this quotation mark, the last one, is the closing of the string. If I print it, my mother said, single quotation, do your homework, just like that. So once again, you have to be careful because you don't want to mess up the formatting of this fprintf. The 2% signs, just like we did earlier, will place a single % character. Now this one might seem weird because there's nothing to do with it, but we're going to look at in just a second why we're going to do that, because the % sign singularly will actually mean something else in MATLAB. So if I want to say, I don't know, fprintf, this is a % sign. Just double %. There's a % sign, it places a single %. So sometimes you need to be aware of some of the nomenclature when it comes to this and how you format it the way you want to, because if you don't do it correctly, you might get an error, you might get something printed that you don't necessarily intend. So now we're going to look at placeholders with fprintf. So a placeholder can be used with fprintf to allow for proper formatting when wanting to display a value that might already be associated to a variable, or a value where you want things to be formatted nicely, for things to look very nice. Integers, floats, and strings, etc. Those can all be printed along with other text by using placeholders. And this is not going to make sense at first, but bear with me. To display an integer along with other text using fprintf, place the characters, so this is specifically for an integer. This is an integer placeholder. To place an integer along with other text, place a %d in place of where the value would go in the text. After entering the entire string in fprintf, add a second argument to the function, being the integer value, or the variable holding the integer value. So the best way to see this is just by an example. So if I were to say fprintf, the integer chosen is %d, I put a \n to say start a new line, or just enter. Then I close my quotations, then I put a comma, and as a second argument, I put a 34. What that's going to tell MATLAB is this %d is a placeholder, and the next argument given in my fprintf function is going to be the value to put in place of that %d. So that means that this 34 is going to go in place of that %d. So the message displayed is the integer chosen is 34. No %d or anything like that. It plugs that value in while beginning a new line below because the \n. So let's try this out. I could say fprintf, the integer chosen is, I could say %d. I'm going to put a \n to start a new line. I need a second character because now that this %d is here, MATLAB will expect a second argument here. So the integer I want to choose is 34. If I print it, it says the integer chosen is, and it plugs that 34 right where we have the %d. It works very methodically. It works exactly as you'd expect, but you need to be careful when using the placeholders. If I were to forget see what happens if I were to forget it. The integer chosen is, and it just ignores the %d. It just doesn't do anything because we didn't offer a actual value to put in for %d. So make sure you actually put a value in if you want to use the %d. Looking at some more placeholders, a float value can be displayed using fprintf by using the characters %f in place of where the value would go in the text. So similar to an integer where we use %d, for a float value or a decimal value, we use the %f placeholder. When using the placeholders for float, one can decide how many decimals to display by editing the placeholder. This is something different, something that we can't see with the integers because there are no decimals. But we can actually tell them how many decimals we want displayed out of the whole number we give them. So place a decimal after the % along with the number of decimal points wanted from the value. For an example, %.3f used as a placeholder will allow 3 decimal points to be displayed in the text. Decimals will always round up or down depending on the next decimal place. As you know, 0.5 or above rounds up, below 5 will round down. So once again, let's look at an example. So if I were to use fprintf float value, you put a colon, so I use the % placeholder just like I would for the integer. But in this case, I'm saying %.2f \n. That means I'm going to put this decimal in here, but I'm only going to want 2 decimal points. That's what the 0.2 means. But here I'm giving a value with 3 decimal points, 0.327. It's going to display float value 54.33 because the 0.2 tells us we only want 2 decimal points. So let's round. So the 7 is going to make it round up to 0.33. So let's actually try this out. So I can say fprintf float value, and then I'm going to put %.2f. I'll put a \n, and then I'm going to say 52 or 52.327. Float value 5.23 e to the 0.2. So, as you can see, my problem here, I used the d. I used a d instead of an f. So it's going to expect it's actually going to expect an integer. So that's why the formatting is weird. So if I actually put an f, it says float value 52.33. So you have to be careful of whether you're using float values or integer values, like I did here. So because of the 0.2, it only went to 2 decimal points, 52.33, which is exactly what we expected. So a character can be used as the value being printed by using the %c placeholder. So once again, this is very familiar to what we're doing already. We can't, there's no decimals with characters, so we don't have to worry about that. But I can say fprintf, my favorite letter. and then I can simply put a %c, meaning that's going to be a character. I put the \n to say I want to start the new line, and then for the character, let's say I just put like S, for example. My favorite letter, and it puts the S right in there because S is a character. Very similar to characters, if you want to put a string value, you could put that using the %s placeholder. So just like that, let's say fprintf a random string :% s \n. String I could put in here, for example, is, I don't know, dog. So if I click enter, it says a random string, and then it plugs that dog into the %s. It plugs it just like in there because %s means it's a string. Multiple placeholders can be used in one fprintf statement, but each value must be added as an additional argument in the order of appearance. So that means that if I have, say, 2 different values I want to plug in, I can do that, but when I add them in arguments later, I need to put them in the correct order. So let's look at this example. I could say fprintf, my favorite letter is %c, but my favorite number is %d. I want a character here because it's %c, and I want an integer here because it's %d. So then I need to add 2 arguments. So for the first argument, I add the z, because the first placeholder to appear is the %c. For the integer, I add 13, because that's second, because the %d is the second placeholder I have. So let's say I actually put this in MATLAB. I'm just going to copy and paste this, because I'm going to keep going back and forth trying to remember what it says. So fprintf, my favorite letter. Okay, it kind of copied my quotation marks a little wonky, so let's edit those real quick. And then it... Alright, so let's look at this. My favorite letter is %c, but my favorite number is %d. I have the z, and I have a 13 as my 2 arguments separated by commas. If I click enter, it plugs those right into the correct spot. The z is the first one, the 13 is the second one. It's very methodical. It works exactly as you'd expect. You can have as many placeholders as you want. Just make sure the correct number of placeholders has the correct number of arguments being added. So if you have 2 placeholders, you need to have 2 arguments going after it. Padding with placeholders. So this is one of the most powerful tools that fprintf has, and a reason why it's so much more powerful than display is that we can use padding. Padding is a technique in which white space can be added to allow for better formatting of text. After the % in the placeholder characters, an integer can be placed to allow for a certain amount of padding. So essentially, we can format things a little bit nicely, and I have an example at the end to show how nice this can all be. But so if we use the placeholders properly, we can put a certain amount of white space before or after a value to allow for better formatting or to make things nicer. So let's go over this a little bit more. As an example, let's use the integer placeholder %d. %kd will require that the integer value take up k spaces of text. So whatever value you put in place of k, that tells MATLAB, hey, you need to make sure this integer value takes up k spaces of text in here, where a space of text is every letter or digit, one of those values. It has to take up 10 spaces if k is 10. If it does not take up 10 spaces, you need to place white space so that it takes up 10 spaces. So if your integer is only 2 spaces long, like a double digit number, so like 24, if it's only 2 digits like 24 and you want to take up 10, it will have 8 spaces of white space before the 24 because it has to take up 10 spaces, and 10 minus 2 is 8. So notice I said before, this notation will place white space before the integer value if the integer is not long enough. And I have an example here. I can say fprintf, I have %10d, that means take up 10 spaces of text, dogs. And then I put 5, meaning the number that's going to go in here is 5. Let's see what happens. So fprintf, I have %10d dogs. So then I'm going to put 5 here as my value, and look what happens when I click enter. So I have, and then I have all this white space here, and if you count it out, it should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it actually will give you exactly what you want. Well, I forgot about the space, so it won't actually start here, it'll start here, because I have the space, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. So the 5 is taking up 10 spaces of text. It took up 10, but since the number 5 is only 1 space of text, it had to place 9 spaces of white space before where we last had off. The reason why there's that extra one is because we have the space after the word have. This can be really nice when you want to format things. That was the example here. We can also pad things a little bit differently. We can have the white space be placed after the number if we want to. %-KD will also require that the integer take up k spaces of text, but unlike the previous example, the negative sign will place white space after the integer value if the integer is not long enough. So in this case, the white space is placed after. So let's try that same example, but instead put a negative sign. So let's say I have that same example, but instead of %10d, I have %-10d. If we place this, now the white space comes after the 5. So it does the 5, realizes that's only one space of text, and then places 9 spaces of white space in order to meet that 10 text required maximum, or the value that we need because of the %-10d. Once again, this is a formatting trick that we can use. These padding techniques can be used with any placeholder, so character, string, float, integer, all those can use the padding values, the -10, you can put +5, you can put any value you want to for your placeholder. Note, use placeholders cautiously with the float values. Rounding, decimals, and padding will make placeholders have multiple components. So let's look at this example here. I have, and this is a complicated thing we have here. So we have the $sign, that will simply print the $sign. Then I have %-12.2f in my account. So that means that we have 12, we want there to be, take up 12 spaces of text. So this value that we print will take up 10 spaces of text. The negative sign means that the white space will be padded after the value, not before the value. And the 0.2 means this number we have is going to round accordingly so that there's only 2 decimal points being shown. So I'm going to copy and paste this into MATLAB. So if I copy, I paste it here. So it automatically clicked enter. Once again, the formatting was weird, so I have to edit that formatting real quick. So if I change that to a quotation, change that to a quotation, this all looks correct now, and I print it, look what we have here. It says I have, it gives me the $sign, it rounds this number correctly to 2 decimal points, it gives me some extra space because I wanted it to take up 10 spaces of text. I had 1, 2, 3, 4, 5, 6, 7, so it adds 5 more spaces of text right here because that's what I said, it has to take up 12 spaces in my account, so it works exactly the way we'd expect it to. And I have a couple examples that we can look at here. Alright, so example 1, ask the user to enter any number and save it as the variable num. Then have the command window print a statement repeating the number back to the user. Alright, so we want to use 2 commands here. We want to use the input command and the fprintf command, because first we want to get a value from the user, then print it repeating it back to the user. So I can say here, let's see, num equals input. And I could say enter a number here. So that's going to do exactly what we want. It's going to ask the user for a number, say enter a number here. And then, but then I want to use an fprintf command. So to do that, I'm going to place a semicolon. And then if you place a semicolon with MATLAB, I can actually start typing a new command on here and it'll execute both commands at once. So I can then use my fprintf command. I can say fprintf, the number you entered is, and then let's say they type an integer, for example. In fact, I can actually make it so that we can change that. Let's say enter an integer here, just so they know for sure. Enter an integer here. The number you entered is, and then since it's an integer, we're going to use %d. I'll use the \n because that's going to be expected. And then this is exactly what we have here. And then we have to actually put the value we want to be in place of our placeholder. So the number that's going to be associated with it is this variable right here. It's going to be num. So in place of the %d, we're going to put whatever the user entered as our value for num. So let's see what happens when we run this. Are you using input? Oh, I made a mistake I've talked about earlier. Remember, you can't use the double quotations when you're using the input function. You have to use the single quotations. So now this will work accordingly. So enter an integer here. So I will enter 56 as my integer. And then if I click enter, the number you entered is 56. Worked exactly the way we wanted to, and it even saved num as a variable in our workspace over here. So this is how we used both commands in order to take in a value and then use that value and used fprintf to display it. Now I have an example here talking about formatting and how we can use formatting to our advantage. So example 2, create a roster of 3 people in the command window. Include each person's name, age, and current grade, 2 decimal points. Use proper padding techniques to format the roster nicely. So let's just kind of do this little personal project we have here. So let's try this. So we want to create a roster. So let's start from scratch here. So we're going to use fprintf, and we want to display a name, an age, and a grade. So I want things to be formatted nicely. So I want a certain amount of space to exist between name, age, and grade, because we don't know how long someone's name could be. We don't know how long the age or grade could take up. So instead of trying to guess with spaces, because every person's name will be a different length, so how do we know how many spaces to enter? We can use padding, we can use formatting here. So let's say for name, I want it to take up 18 characters of text, no matter what. So for the first line, I'm going to say %-18s. And I'm going to put a negative because I want the white space to come after the character. I don't want the white space to come before whatever the person's name is. So I'll say -18, %-18s. This first line I put here is just going to say the words name, age, and grade. So all these are going to be strings. So let's say for the age, I want it to take up 8 characters of text. So I'm going to say %-8s. I'm going to do the same for grade. I'm going to say %-8s. Then I'm going to put a \n saying that I want to start a new line after that. Now I need to say what I actually want to get put in for those 3 placeholders. So I legitimately want the words name, age, and grade to appear, because those are the 3 categories we have, and I want them to be displayed nicely. So let's say we enter just that. So we can see we have a little heading for ourselves, name, age, and grade. So now I think I also want to include, let's just put some equal signs to kind of make a bar for ourselves. So I'll put a semicolon, fprintf, and I'm going to just put a bunch of equal signs here. Maybe that'll be enough. Let's try that. Along with a \n so that we can start a new line after. So you can see here, now we made ourselves a little, that's going to be the top of our table essentially. It's going to be name, age, grade. We have a little table. I'm going to do a few, or I'm not going to do as many equal signs. There we go. So that looks a little bit nicer. So now we're going to start entering people's names along with it. So we can do, let's say we can do like 1 person as an example to start off with. So let's see, I'm going to clear that. So I'm going to have the rest of this. So I'm going to start this next command, this next fprintf on a new line. So I'm going to put a semicolon. To put something on a new line but still have it all be part together so MATLAB doesn't run, I can type ... and then enter, and then my little cursor went over here. So now I can start a new fprintf line if I want to. So I'm going to say fprintf. So now I'm going to use that same formatting technique, that same padding. So I want the name to be 18 spaces long. So I can say %-18s. It's a string that'll take up 18 characters. Let's see, so this time I want the age, I still want to take up 8 spaces of text because that's the same as the heading does, but in this case it's not going to be a string, it's going to be an integer because someone's age is an integer value. So I'm going to say -8, but instead of s, I'm going to say d for an integer. Then for the last one, I want their grade. So I'm going to do %, and their grade is going to be a decimal value. It's going to be a float value. So I want -8. But let's say the grade, I want it to round to the nearest 2 decimal points in case, I don't know, someone's grade is more accurate than that. So I'm going to say -8.2f. Then I'll put the -n, close the quotations, and now I'm going to fill in my arguments. So what should the person's name be? Let's put my name. So I'll say I'm Steven. My age, I'm currently 19. And so for my grade, what should my grade be? Let's say my grade's 87.455. That's going to be my grade. So let's see what happens if I print all 3 of these fprintf commands together. And notice I'm not doing one big fprintf command. That's because then I'd have so many arguments and so many placeholders, it'd get very confusing. So splitting it up between multiple fprintf commands will make it much more nicer for us to actually format. If I click enter, so look how nicely everything formatted because of the padding we used. So my name took up some space, but the 19 immediately got put right under the age category, and the grade got put right under the grade category. Because of the padding, we use the exact same numbers, so because of that, everything looks so nice. So now we can do this again. You can see, enter that, and then we got that. So let's type another person. So I'll say fprintf. We'll do the exact same thing. So it'll be negative 18, or probably put the percent sign. So percent negative 18s, percent negative 8d, percent negative 8.2f. I believe that all matches up. Dash n. And this person, let's call this person will be Bob. His age in this case, he'll be, let's say he's 21. And his grade, let's say he got a 97.341. All right, so if we click enter then, let's see what happens. Once again, now Bob is here, but notice that still the age, even though Bob was fewer characters, only 3 characters, the age still got put exactly where we wanted it to. We didn't have to worry about counting spaces or knowing exactly how many spaces to put because of the padding. Everything looks so much nicer. And now, just cause, let's add one more person in there. So we got that. Let's just add one more person to kind of finish it all home. It's the exact same technique. So we got percent negative 18s, percent negative 8d, percent negative 8.2f dash n for the new line. This person's name will be Bartholomew. Let's see his age in this case. Let's say he's 34. And his grade in the class, maybe Bartholomew's not doing so hot. He's got a 43.897. Ooh, he's doing okay, but yeah. So let's see what happens when we print all these out. Everything still looks so nice. It looks formatted so great because of using fprintf. If we tried using display, we'd have to count out all the spaces that we want. We wouldn't be able to format it so nicely. And that's kind of the power of fprintf in using this, is that we can create something that looks so nice like this. And so really the takeaway of all this is that the input and output can be used so that we can really communicate between MATLAB and the user and print things out nicely for the user and have the user input numbers. Once again, all this might seem a little counterintuitive just because we could just type values on the command window ourselves. But in the next video, we're going to look at scripts and how to make scripts. And what we can do is we can hide all these different functions and stuff so the user doesn't see them, but still have things be displayed nice and have the user be taking values in for input and all that. So thank you.